A few years ago, I experimented with making short videos. I briefly tried to highlight subsea news or explain technology in around a minute. It took such a long time to do. But the other day I thought I really ought to give it another go. And I was going to do this to coincide with the Oceanology show in London, reviewing some of the technology there. I had everything set up and then the show was postponed. So these are the things we missed that I was actually looking forward to seeing. And we'll do that in, I don't know, a couple of minutes. And we'll start with Magellan, a first-time exhibitor. A considerable portion of the world's ocean floor lies in water depths of around 6,000 metres. Seabed mineral deposits were actually discovered in around 1875, but it's only in the last decade or two that people have recognised the practicality of subsea mining. Exploiting this resource will provide opportunities for companies capable of carrying out work such as site investigation, lifting, subsea mapping, bulk sampling, recovery and intervention, all in ultra-deep water. And that's a problem. Traditional underwater systems struggle to cope with prolonged exposure to the severe conditions found at these extreme water depths. It's this that prompted the establishment of Magellan. Its commercial objective is to develop systems and techniques that allow it to work and operate continuously in these niche areas. Magellan's principal, Richard Parkinson, who would have been at the show, would have no doubt explained that there are companies that can bounce down to 6,000 metres on the seafloor, but to date nobody has amassed the expertise to work there for sustained periods and be available on site all day, every day. So, for the past 6 months, they've been doing just that, developing and bedding in systems. They've selected a pair of Argus electric work-class ROVs, each with different tooling pack configurations, which they'll operate simultaneously. SimOps accelerates work, increases availability, and allows them to react rapidly to the sort of unexpected problems characteristic of working in any frontier. If you want to know more about that, there's a huge article in UT3. But I asked Rhys McAllister, the general manager, if there really was a difference between working in the maximum depth the oil industry works at, 3,000 metres, and the 6,000 metres that they wish to exploit. And he said, at these depths, reliability is everything. The most obvious challenge is the greater ambient pressure that the equipment has to withstand. And this can cause frame distortion. And once that happens, the fixings come loose and the buoyancy starts to move. And at these depths, buoyancy accounts for around 90% of the lift weight. To counter these problems, Magellan have had to source and test many components. It also involved the developing of techniques. ROV companies handle maybe 1,000 metres length of umbilical cable, so handling 6,000 becomes a real issue. They considered that the conventional tether management system would actually provide an unwanted level of complication, so they developed their own handling system. The ROVs are electric, but of course they incorporate hydraulic circuits. Magellan's, however, use seawater instead of hydraulic oil, something you never really run out of at these depths. And another interesting thing he said was the environment is anoxic and clean, and this allows them to wet store a lot of tools and tooling skids on the seabed to mitigate rust and corrosion and reduce unnecessary cycle times. If you want to know more about subsea engineering, read UT2 or UT3, the online version.